The Professor's Digital Dojo.
Alright folks, welcome back to the dojo. We're going to do a short tutorial on setting up a sequence render, and I think I'm going to use one of our Bifrost graphs as our sample file here. So here we go. Alright, first things first, make sure your resolution gate is turned on, as mine is here. Second, we're going to open our render settings. Make sure our image format is set to EXR. Next, under frame animation extension, I want to change it to name.number extension, and then I'll say how many frames I would like to render. Maybe for you it's 100, 200, 300, 450, whatever. So I'm punching in 100 here. Next, under preset, I want you guys to set it to 1920 by 1080. And so this will be our compositional space. Now the next thing we need to do is we're going to do a quick test render just to see what the quality of our sampling is like here at default. Now I have a Skydome light with an HDRI file mapped to it, which means I may have to sample things a little higher. I also have my camera set with a shallow depth of field. Again, that means I might have to go with samples that are a little higher than normal. Now, once again, when I'm rendering for a sequence, I cannot use the Arnold denoiser, so I need to turn that off. And you'll see that my image is noisier than it was before. Remember that the Arnold denoiser is not temporally stable. What that means is it's great for denoising single still images. However, if I'm doing a sequence, it is not appropriate. So I need to sample things maybe a bit differently. Now, we can muck about with our settings to try to figure out what's the ideal settings, but the best way to do this is to set up AOVs so that we can see where the noise is coming from. And here in our render settings window, we've got everything set to default. I turn transmission, subsurface scattering, and volume indirect down to 0 because I do not have any of these things in my shader. If I did have them in my shader, I would need to include them into the sampling as well. So let's move over to AOVs here, and we're going to add just the few that we need. For now, it's going to be diffuse, diffuse direct, diffuse indirect, specular, specular direct, and specular indirect. They may say, why are you adding these to the scene, these AOVs? And if you look once again, we're sampling camera AA, we're sampling diffuse and specular, and that's why we're choosing these particular AOVs, because we want to see the diffuse and specular AOVs. I'm going to close this just for a moment. We'll pull our render window back up, and I'll bring the video back on when all of our rendering is done. Alright, you can see here that my render took about 25 seconds with the samples set where they are. Again, the Arnold denoiser is turned off so that I could see what final render quality for an image sequence would look like. Hopefully you guys can see that this is a bit too noisy for a final production render. Now, a good bit of this noise is coming from the fact that we have the camera depth of field set on and we're set at a shallow depth of field. The only way to remedy a shallow depth of field bit of noise is to increase our camera AA or anti-alias settings. However, if we go to our AOVs now, and we can access them up here in this drop-down menu, we can see that our diffuse is clean for the most part. Diffuse direct, that's the light that's hitting our albedo directly, is pretty clean in those areas that aren't shallow. Looks not too bad. In diffuse indirect, this is where the light is just bouncing in. You can see that we're pretty dirty. This is a pretty gnarly looking render. Next, if we look at specular, they're not super shiny. Specular's got a good bit of noise in it as well. And if we go to specular direct and specular indirect, we can see that we've got a lot of noise in there. So that already tells us that we need to resample our diffuse and specular aspects of our render. For that, we're going to come to our renderer here, and we're going to push diffuse up to, let's say, 4. That should do it. And we'll bring specular up to about 3. And our camera AA definitely needs to go to about 4. The other thing I want to do at this point, remember that camera AA here is helping us clean up that shallow depth of field. The next thing I want to do is I want to check my sky dome light and make sure my samples are set high enough. I'm going to push them from 3 to about 5. That'll also help to clean up the scene without increasing sampling here and without increasing render time substantially. So again, I'll pause the video and I'll bring it back up when we're done. And as you can see here, things have gotten quite a bit better. Let's look at our before and after, especially if we start to look in areas like this. I'm zooming in quite a bit. You can see that we've cleaned our render up. Now, the only thing is before our render was at 25 seconds, and now we're at 1:20. So we need to look at a few ways to clean this up. There's a couple of things we can do. The first thing we can do is check our shader and make sure it's not too shiny. That'll clean up our specularity. So I'm going to sort of sample this and take a look. Right now our roughness is set to 0.2. If I set this to about 0.35, we would still get a similar amount of shininess. However, we wouldn't get quite as much specular noise. I can also bring down my base weight just a little bit and correct that in post. In other words, it'll be a bit grayer than I want. However, it won't be quite as white. And then we won't be as shiny. So that'll help us there. So that means I can sort of come up to my render settings. And again, this is about balancing things out, and I can bring specularity maybe down to 2 at this point. Next thing I'll want to do is take a look at the sampling here, and I might bring it up to something like 8. Now I don't want to go too high. However, our goal here is to bring our render time down or to keep it as close to the same as we can while still improving, while still improving the final quality of our render. So I'll pause this and we'll take a look at it and see what we've got again. And here we are. We have a fairly acceptable render. Remember, here was our previous render at 1:20 seconds, and now we're at 1:29. Now, my goal is really to clean up this noise, to bring our render time down, and to improve quality. We can't do all of those things if we're going to render depth of field here, what's called in camera. And that means having the depth of field set right here in the Maya workspace using Arnold to render it. I'm going to stop it here. And so what I'm going to do is I'm going to show you guys something. We're going to go to View, select Camera. I am going to turn off under Arnold. Now it doesn't mean you have to, but I'm going to turn off Enable Depth of Field. That will allow me, 1, to bring these samples down to maybe about my camera AA to like 3, and diffuse to maybe 3, just for the moment, so I can take a look at what that render is going to look like. I want to speed it up. The reason I'm doing this is because I can actually add depth of field to the image in post. And I do that by adding a Z-depth AOV. Whoops, let's move up to the top. And it's right here. This is known as a Z-depth AOV. Now I've got to do a couple of things when I do this. I want to select it, and under Z, I'm going to change float to... No, I'm going to leave that as float. And I'll change this to Gaussian. And for driver, I'm going to use EXR. And now this might be a separate tutorial that I'll do. However, I'm going to include this just so we can speed up our render time, and we won't have depth of field in the exact render, but when it comes time to composite it or to work in DaVinci Resolve or Nuke or whatever is our compositing program, I can actually use that Z-pass to add depth of field after the fact. Fancy Latin term meaning expose facto. Pause the video for a moment, and then we'll take a look at our render now. Alright, so now we've got our render down to 41 seconds. You can see that our depth of field is gone. However, it's about the same amount of noise in our diffuse pass that we had before. And if we check our AOVs, you can see that our diffuse direct is clean as a whistle. However, our diffuse indirect is where we're getting a lot of that noise. That comes from using the HDRI, which uses a lot of bounced light, so that's something that I'm expecting to see. Our specular is likewise a little bit dirty. Direct looks good, but specular indirect, again, coming from that bounced light, is a little bit dirty. So we're gonna do a kind of show you a trick here. And you guys want to know about rendering, so this is how it works. If we're using something like the Skydome light with an HDRI, let me set the proper resolution here, and we're using an HDRI light. One of the ways that I can decrease the noise in this shot without really increasing any of the samples in the camera is to add a second light to just sort of give this a little bit more fill. Notice our locator is about right here, so I'm going to put my fill light kind of pointed right at the locator. I'm going to use a spotlight, just like so. Let's increase that size a good bit so it's more actionable on our screen. Let's move that out. Let's zoom out a bit here. Let's really bring that spotlight out here. I hit T on my keyboard to bring up the manipulator, and let's put our spotlight pointed kind of right about at the same place that we're viewing our strings formation. I'm also going to lift that up just a little bit here. Now, this takes a little bit of tweaking, but it works quite well. We're going to set our quadratic decay. We're going to go with a much wider cone angle here. Under Arnold, we're going to set our exposure to about 12 to start. We're going to set our samples up to about 4. And we'll play with radius and things after if needs must. However, we're going to pause for a second. We're going to take another look at this render. I'm not changing any settings. I just want to see, I want you guys to see how it's going to look just with another light added into this area. And there we are. We've got ourselves a much cleaner render at around 46 seconds. The reason, now I can tweak this spotlight more so that it matches everything a little bit better. The reason it works so well though is now I'm not relying on so much bounced light in my diffuse indirect and my specular indirect. I have an actual light doing some of the work for me. So it helps to clean these areas up just a bit. And honestly, for what we're doing in class, this would be an acceptable amount of noise in the render. I could actually show you guys how to remove some of this noise using DaVinci Resolve. Now for a cinematic plate, this would not be quite good enough. Of course, we would have to go a little bit stronger. Now I will set everything up so we get a perfectly clean render. I'm going to take a snapshot of this so that you guys can see what a perfectly clean render looks like. However, you will also notice the time commitment that we have to contribute to a perfectly clean render. And that's simply part of the game. Very, very clean renders that are highly precise take a little bit of time. Not a massive amount of time. Well, it depends on the scene, to be frank. But anywhere from a minute to a very complex scene with very complex shaders could take 45 minutes to an hour per frame. And that's one of the reasons render farms were designed. I know you guys don't have a render farm, we don't have a render farm, so I'm trying to get us as close as we can to a clean-ish render within the sort of purview of the sort of equipment that we'll be using. So again, I'll pause the video, I'll get us a perfectly clean render, and we can take a look at the difference between the two. Alright folks, and now we're looking at what's called a dead clean render. This is, you can see the difference, this is our before, and we'll zoom in here a little bit, and after. We've got ourselves a pretty clean render. Won't be a lot of dancing pixels in this. Any noise that would show up I could easily handle in post-production. However, let's look at before, we're at 46 seconds, and for a dead clean render, we are now at a minute 58 seconds. Now, for my purposes, a minute 58 seconds per frame is more than acceptable. Anything under 10 to 20 minutes per frame I'm really happy with. However, I know with the strictures of your lab equipment and the amount of time you have, that that's not practical. So I want you to know that this 46-second render right here, pardon me, would be acceptable for our purposes. Now it's not dead clean. It won't look as perfect and once it's animated. However, it's almost as good as this one for what we're doing. Now let's say that we're happy with this. Let's set ourselves up to do a render sequence. If you're not already in your render module, I'd like you to switch to your render module and then go to the rendering menu and open up render sequence. Now, if you followed my other tutorials and you created render layers or using the render setup for multiple cameras and multiple layers, then you'd want to check the box that said all render enabled layers and all render enabled cameras. Right now we only have this single layer, this single camera. And so I'm going to make sure that my current camera is set to my renderable camera, which normally I would not use the perspective camera as my render camera. That's my Uber camera. I kind of use this to work. I'll create my own custom cameras from scratch, but because it's a demo, we're just using what we have right here. Hopefully that's understandable. We need to make sure the proper camera is set right here. Next, I'm going to put an output location. I don't want Maya putting it in the normal place. I want to go put it someplace with, as I call, a bit of real estate. I've got my own drive here. It's called the Ragnarok drive, and we've got put it sequences. I'll tell you what, I'll go to my different one here. I'll put it in renders, and then I would put it in a folder like so. I would select that folder, and then I would click render sequence and set it and forget it. And what that means is once I click render sequence, I don't want to do anything else with my computer. I do not even want Google Chrome running. I want nothing but Maya. Maya will take 100% advantage of my CPU at this point, and I want it that way. If you have a laptop that tends to run hot, or a computer system that tends to run hot, put a fan on it. It may be running 100% CPU for hours at a time, and we just want to keep it cool. Not a big deal. It shouldn't melt. And most processors, well, all modern processors have a TCP built in which they will shut down if they hit their temperature limit. So you don't really need to worry about that. However, nothing sucks worse than waking up in the morning expecting to see a finished render, and instead you have a crashed system. So again, keep it cool. Put it in a cool place, something like that, and let it render out. And that's the end. In the end, we'll have an image sequence that we can compile and composite in something like DaVinci Resolve or Nuke, or if you're old school and you want an inferior product, you could use something like Adobe After Effects. I'm kidding. Adobe After Effects, of course, still has its uses. Now, that's as straightforward and as short as I can make this sort of demo or the tutorial. If you have any questions, please leave them in the comment section and I will do my best to address them, or if you need something clarified, I'll gladly do that if someone asks. Alright, remember to hit that like and subscribe, and hopefully this has been helpful for you guys. Bye bye.